Hello everyone, welcome to this new online course on modern display technologies, flat panel display. I am Dr. Debabrata Sikdar, Associate Professor in the Department of Electronics and Electrical Engineering at IIT Guwahati. We have done this course at IIT Guwahati and found fabulous response from the new generation students, because display is something that we are always encountering in our life. We are using different types of displays, so it is always good to learn a lot in depth about the displays, and this is why we introduced this course, and we will be taking you step by step through different types of displays in this particular course. So this is the first lecture where we will be discussing about flat panel displays. So here is the lecture outline. We will have a brief introduction to displays. We will talk about the history of flat panel displays, and then we will look into the two types of flat panel displays, the emissive displays and the non-emissive displays. And then we will also briefly look into different flat panel display technologies which are dominating the market right now. How do you classify them into different buckets, and then what is the market trend? Why one should learn about this display technologies. So displays basically serve as a man-machine interface that enables the transfer of information to human visual system. So they are basically designed to present various types of content, including pictures, videos, animation, text. Okay, so all these things can be directly transferred to human visual system. So the fundamental purpose of display is basically the generation or reproduction of colors and images. So historically, traditional display mediums like ink on pen, ink on paper, in paintings or books, they basically represent the earliest established form of visual communication. And then you can actually see the difference. This traditional media, they are basically static in nature. So any sort of modifications or updates becomes challenging or more or less infeasible. Okay, it's like you need to basically redo the writing or the script. The other thing is that a natural or artificial light source becomes essential for reading books or looking into any static images, and this is where the modern electronic display technologies have come for the rescue, because here you utilize electronic signals to create dynamic images on panels that can directly engage the human visual system. So here you can see it's a visual representation of a desktop display. Now workplace displays are one of the most frequently encountered displays for any human being these days. Like all of us are sitting in front of desktop or laptop and working almost 30 to 45 hours per week, right? That's a regular time. After that also we spend a lot of time in front of our mobile phone or iPads or television. These are all displays. So our leisure, our entertainment, our work, our information, everything has now become dependent on displays, and that is why display is one of the most important factors that need to be engineered such that the stress on human level is less. You do not excite unnecessarily the stress hormones and other things. So this particular technology should be engineered in such a way that the adverse effect on human health is minimized. Also, you will see that the nature of work and the work environments and the workplace displays, they have undergone significant evolution with time. Okay, people have already seen the advances in wireless and mobile communication technologies. Okay, large screen displays and portable computing have basically transformed the workplace interaction with displays. So you can basically these days stream your laptop to any external bigger display to hold a meeting. Okay, any of your other colleagues or your fellow classmates, they are having their own presentation in their laptop, they can wirelessly stream to an external display. So the means of connectivity via wireless, that has also advanced the usage of this new generation display modules. So if you go back few decades, things were not that green or encouraging, because earlier all of us might have seen those bulky monitors and displays. They were basically single cathode ray tube monitors which used to dominate the workplace. They used to eat up like 30-40% of the desk space as well, but they were the norm, right? But right now, if you look into any modern work environment, people have flexible, portable displays which are very slim, thin, okay, lightweight. You can completely shift them from one place to another and so on. So the display technology over a few decades have tremendously improved, and this is where we need to understand the amount of science technology that goes behind it, so that we can also contribute towards the research of developing more advanced display technologies. So here is an example of advanced display technology. I guess you may guess this. This is basically a smart glass which also shows some additional digital information to the reader who is also looking through the glass to the real world. So we'll come into all these different types of modern displays, but first let us look into the history of this flat panel displays. We'll not spend too much time here, but we'll quickly have a look. So in historical term, one of the most successful technology for home entertainment was this guy, CRT, cathode ray tube, okay, that basically enabled the widespread adoption of television. And I believe every Indian household might have seen this kind of television for certain period of time, okay, and it exhibits advantages of being self-emittive, okay, and offering wide viewing angle, fast response, good color saturation, long lifetime, and also it had a good image quality, okay. Now the only disadvantage, or I should say the major disadvantage this display had was its size, and it was because it's very bulky, right. So usually the depth of a CRT, cathode ray tube, is roughly equal to the length or width of the panel. So if you take an example for say a 19-inch CRT, okay, which has got an aspect ratio of 4:3. So this is say 4 and this is 3, 4:3, that's how they calculate it. 19 inch is typically the diagonal length, okay. In that case, the depth of the monitor has to be around 40 centimeter. So as you can understand, because of this big size, so this whole thing is typically 40 by 40 by 40, so it's basically very bulky and it is hardly portable, right. And the heavy weight, that also adds to its limitation. So then gradually people have come up with different technologies that could replace the CRT, and that is how people have come to this modern television, which are sleek and wider, and it has got more colors. So these are basically the digital televisions, right. So here the display basically again act as an interface to convey information, including images, animation and text, to visual human system. So nothing has changed, the kind of technology has only evolved, the purpose remains same. But the good thing about the modern electronic display system is that they can create images using electronic signals, okay, providing dynamic and visually stimulating content. So these technologies enable flexible and interactive content presentation without reliance on external light sources, okay. So with that, we will now look into different types of flat panel displays. So if you try to put them in two categories, you can actually divide them into emissive and non-emissive type, okay. So the emissive one basically tells you that the display element, okay, the pixels, they are basically emitting light on their own, okay, and non-emissive, as you can understand, they do not actually have their own light source inbuilt. In case of emissive displays, the pixels basically emit the light directly with varying intensity and color, so that could stimulate human eyes directly. On the other hand, non-emissive displays modulate light that is coming from the back. So, you need a backlight source, okay, and this non-emissive displays basically modulate the incoming light by means of absorption, refraction or scattering, and that allows them to display the colors and images, right. So, these are different types of displays commonly people use. The CRT monitor and the CRT television, these are now obsolete, you can't see them anymore. And then you have LCD, this is also very popular, and then the LED. So, we'll mainly focus on these two and tell you that which one is emissive and which one is non-emissive. Okay. So, let's first focus on emissive displays. So, emissive display, their light is basically emitted from each pixel, okay, which forms a part of the image on the panel. So, the examples of emissive displays are CRT and LED panels and also the OLEDs, organic LEDs. So, semiconductor LED or organic LED both are falling in the bucket of emissive display, because here the pixel itself is giving out the color, they are emitting light. So, what are the characteristics? Ideal emissive displays are basically Lambertian emitters. They can provide constant luminance from all viewing angles, and they are suitable for low ambient light conditions due to their self-emissive properties, because they themselves are emitting light. And you can get high contrast ratio under low ambient light, as they can appear completely dark when turned off, other than the ambient reflection will be coming from the outer surface, right. So, when you switch off the light emitting elements, so you get a complete dark. On the other hand, when you talk about the non-emissive displays, so the name itself suggests that here these displays do not emit light directly, they basically rely on some external light source. So, these are called backlights. An example to this is LCD, okay. So, LCDs are basically non-emissive displays. LCD stands for liquid crystal display. So, in this kind of display you have liquid crystal molecules in each pixel, which basically work as a light switch independently of the other pixels, okay. So, an external voltage can reorient the liquid crystal direction, so which basically controls the incoming light's phase. So, whether it will be allowed to pass or not, that is decided based on the applied voltage across the liquid crystal. So, the liquid crystal basically modulates the transmittance of the light, okay. So, it will go into the details how it works. So, just to understand briefly, applied voltage basically controls the transmission of light through the polarizers. There will be two polarizers required in this setup of LCDs. So, if you do a simple comparison, the emissive displays, they have direct light emission, so they are ideal for wide viewing angles and low light environment. On the other hand, non-emissive displays, they require external illumination and operates via light modulation. So, they basically modulate a backlight source, okay. So, there is a backlight source which gives out light, okay, and then you have this liquid crystal panel, okay, where each pixel can allow the light to come out or to be stopped, okay. So, that way the display works. Now, the non-emissive displays can be further classified into transmissive and reflective type. So, till now I was telling about the transmissive type, where you have a backlight source and you have a liquid crystal kind of film that is basically either allowing or blocking the light. You can also have another type, that is a reflective type, right. So, if the light source is behind the display panel, it is transmissive type display. On the other hand, it is also possible to use the ambient light as the illumination source. So, that basically imitates the principle of traditional media, such as reading a book. When you read a book, you need external light source, okay, because the light is basically reflected from the book and then getting into your eyes. Similarly, reflective displays, which are non-emissive in nature, they also require a external light source, and that is why they are falling in the category of reflective display. So, one benefit is that as you do not require an external light source for reflective display, the power consumption is relatively low. Now, under high ambient light condition, so the images on emissive displays and transmissive LCDs may be washed out, because if your ambient light is very bright, whatever light is coming out from your transmissive display or emissive display, which are emitted by this small, say, pixels, okay, they may be washed out. But what will happen to the reflective displays? They will survive because they are based on the light source, which is basically external. So, reflective displays will exhibit higher luminance as the ambient light increases. So, in a very bright ambient light condition, you can go for reflective displays. However, you cannot use them in dark condition. When there is no reflective, no external light source, reflective displays will be useless, because you do not have any external light to be reflected on your display and reach to your eye. So, in that case, emissive or transmissive type display will be better. So, with that, we will briefly look into different flat panel display technologies. So, let us first have a brief overview of these different flat panel display technologies. The first one, as I named, is LCD, which is very popular. LCD stands for liquid crystal display, and we briefly understood that LCDs basically utilize liquid crystals to modulate light from a backlight source, okay, for producing images with good brightness and cost efficiency. Okay. However, the contrast is limited by the need of external illumination. Okay. Now, this is one side, this is the non-emissive display. Then you have the emissive displays, which are LEDs, light emitting diodes. There are different types of light emitting diode displays. One is called direct view LED, mini LED and micro LED, okay, based on the sizes. So, these displays basically use arrays of light emitting diodes as individual pixels, or they can also go for backlighting of LED screens. Okay. So, you can use them as backlight unit as well. What is the benefit of using LED is that they offer extremely high brightness, they are durable, and especially for micro LED, you can get excellent contrast and efficiency without any need for traditional backlight. When I say you can use this display, the LCD display requires a backlight. So, the typical backlight is done by CFL, cold cathode ray fluorescent lamps. Okay. You can also use LEDs as backlight for LCD monitors or displays. And LEDs on their own, they are emitting light, so you do not require any backlighting for them, right. They themselves can be either backlight or they can be a whole display. Then you have organic light emitting diodes. So, the one here were basically the semiconductor light emitting diodes. You can also have organic light emitting diodes. They are basically displays. OLED displays are basically based on self emissive organic materials that can emit light when they are electrically excited. So, they allow true black, that means you can get very dark blacks. This can also give you high contrast ratio and flexible form factor. Next, these days you may also be hearing about quantum dot displays. Quantum dot displays basically employ semiconductor nanocrystals or quantum dot to enhance color purity and brightness, and they are basically integrated with LCD or OLED architecture for wider color gamut, that is the color range they can cater to, and they can also have improved efficiency. The next category belongs to e-paper display, which is electronic paper display, that basically mimics the printed paper, and this uses electrophoretic particles, and they basically consume very low power, and here maintaining an image is possible without continuous refresh. That means that makes them ideal for static contents like e-readers or Amazon Kindle and all these things. So, these are the different displays which are currently dominating the market. Now, if you want to classify these different displays into which are emissive and which are non-emissive. Again, emissive displays are basically the self light emitting displays. So, all the LED displays, the direct view LED, mini LED, micro LED, where each pixel can emit its own light. Okay? So, they basically enable very high brightness and contrast. So, these are all based on semiconductor materials. If you go for organic materials, okay, so the organic light emitting diodes, they are basically based on polymers, okay, and organic polymers, and they are self emissive. Again, their pixels can produce light individually and they can allow true blacks and superior contrast. Okay. But there are some problems with each of these technologies. Okay. So, we will go into details in the due course of time in the course. So, right now we are just trying to understand what are the dominant display technologies that we are encountering every day in our lives. Okay. Now, in the non-emissive display category, which basically requires external illumination, now it is clear that LCD falls in that bucket because it uses a backlight, okay, because that is a backlighting source if it is a transmissive LCD, liquid crystal display. So, it basically uses a backlight. So, if it is a transmissive LCD, the backlight is modulated by the liquid crystals, okay, and the image is formed. If it is a reflective one, there is no backlight, the ambient light is reflected and an image is formed in that way. Okay. Then you have quantum dot display. It is also non-emissive because there also you require a backlight source. Okay. So, typically a non-emissive enhancement layer in quantum dot LCDs are used that basically improves color by using a backlight source. So, how quantum dot technology work? Let me just briefly explain to you. A blue LED backlight is used that shines through a layer of quantum dots, which are those nanocrystals, typically 1 or 2 angstrom or 1 or 2 nanometer, okay, 1 or 2 nanometer in diameter, and each of these can emit light of a specific wavelength, red or green, depending on their size. So, that is how the quantum dot display works. And then you have e-paper display, that also falls in the bucket of non-emissive displays. Here this e-paper display also work on reflecting the ambient light rather than emitting light on its own. So, it basically functions like a printed paper with ultra low power consumption. So, my question is, why are we studying this and why it is going to be very important in next 5 or 10 years? Because these days when you are interacting with more and more devices and gadgets, we are basically looking into their displays. You might have seen the trend that a mobile phone display has gone now borderless, it's bigger over the years. People are going for bigger laptop screen, bigger desktop screen, bigger iPad screen. Okay, you need a bigger display to do a lot of things at a time, right? So, the market trend also shows that the global display market, which was currently $135 billion in 2024, it is going to rise up to 173 billion by 2029. That means it shows a growth rate of 5.1%. Okay, and you see the color scheme here shows North America, the blue one is for Europe and this one is for Asia Pacific. Okay, and you see that Asia Pacific is going to do a lot of contribution towards this particular growth. So, displays are the output devices which basically represent information in either text form, pictorial form or graphical form, which are now integral to all the devices we are interacting with, right? TVs, PCs, notebooks and smartphones. So, that is a very big market, as you can see, smartphones. So, what all different display panel we encounter in our day-to-day life? The liquid crystal display, direct view LED, mini and micro LED. These things are still not too much into the market because they are expensive. okay, but the regular LEDs are always there, okay, and LED TV is also getting in the market. Then you have OLED, okay, those are in your smartwatches, okay, you have TV, OLED TV, quantum dot displays, and e-paper displays and all this. So in this particular course we will mainly focus on these two aspects, okay. We will try to go into the very details of LCD displays and LEDs, okay, the semiconductor one mainly, because they are currently dominating the market, and over the next 5 to 10 years also they have got a very bright future, okay. OLED looks very promising, but OLED has a problem, inherent problem, and because of that people are again going back to mini and micro LED, okay, and that is going to be the future of the display technology, and this is why, okay, we will be focusing mainly on these two topics. So with that we conclude this lecture. If you have got any query, you can drop an email to this particular email address mentioning the course title on the subject line. Thank you.